So, so I welcome you to the first class on programming in C++, and it's going to be a beginner's level course. So before I uh, before I start this class, I would like to mention a few things. Some of the things I even covered in the introductory video which I recorded. So, I thought of typing all these important points instead of just telling you in the lecture, because I want you to refer them again. Maybe it will be helpful that at a later stage if you can review these points. So first of all, these classes are not about learning programming language. So some of the people even asking that why I'm taking these classes, I try to answer in the video. So this is not about programming language, and this is about learning programming, how you can convert logics into code. Because like people are mentioned that there are already so many videos available on the internet, and from Stanford and from Harvard and all. So and they are really nice quality videos. Then what's the point you are teaching this topic again? So my answer to this question is, it is again, I went through those videos. They are good in teaching you the concepts of C++. But our focus in this class is you need to like write as many as programs. It's about writing more and more code. So, and this can only happen when you do along with the class. If and if you have to go take initiative yourself and go and see those videos, and there is no structure, then it is difficult to learn. And idea is that I want to focus on those people who cannot do themselves, who have huge inertia of going themselves and learn programming on their own. And because here not everyone is in computer science department or IT or those kind of IT, so there are people who are from other background also and they want to learn programming. So for them it is very easy if it is more structured, and if they don't have to do on their own, if they know that this is something they have to do this week and this is they have to do next week. So if there is a proper plan, they end up learning more as compared to they are doing on their own. So other thing is Uh, this is I chose C++ as the first language because C++ is the language which, though it's not a language which we use very often in industry, which is not widely used, but still as a at a like college level, it is very important to learn C++ or even C. But there's not much difference between C and C++. Wherever you can see, you can use C++. In industry, C++ is used either for a system programming, or if you have to do where memory is very important or performance is very important, where your performance of the code is comes into picture, or where you have to write code in such a way that it consumes less amount of memory. So but like I want to focus more on industry languages, because I want like people who are not in CS background, they when they pass from college, they can get good jobs. So I'll be covering C++ for a few months, and later after that I'll go on more industry specific languages like Java or Python, or maybe JavaScript, HTML5, those kind of things which can directly be used in industry. So again, I have a third point here, that classes are for those who cannot do themselves, right? People who can do themselves, I really doubt that they'll get any advantage of these classes, because our focus would be to like teach students who are novice here. So if you're already done that, or you can do yourself, you can run at a faster pace, so you might not get any advantage from these classes. The fourth point is that, like, practice makes a huge difference here. It's everywhere. It's for everything. Whatever you learn, you need to practice, and same is true for coding, especially in the initial part might be scary, because it happens with everything. If you have to learn driving, it's so difficult to learn driving in the beginning. It is not a fun, it's a pain, and it's very scary also when you learn driving for the first time. Whether it's a car, you learn how to drive, or it is a bike, even for not the motorbike, I'm talking about the bicycle. The if you would have learned that in your childhood, initially it is very scary, because you need to balance a bike is not that difficult. Same here in coding, is not a fun in the beginning, so you have to cross that initial level, ignition temperature kind of thing, that you need to write your first 50 programs, and after that you get a grip on writing logics into code. You can do this with every programming language. So my goal would be to take you beyond this level, to take you beyond this level, that after that you can learn any programming language yourself, or you can, like, if you have to write even complex code, your fundamentals are so strong that you can write them yourself, or you can at least contribute in complex programming also. So the fifth point is very important, that you need to show a lot of patience in the beginning, because in the beginning when you have to even write a simple program, it takes time, it takes energy to do it right. So maybe if you're, like, for example, you're compiling your program, you're running your program and it's not running, so you are stuck, and mistake might be so simple that, like, but you're not able to figure it out because you have no experience. So you need help from others also. You need to show more patience. You cannot give it up. So initial period you need to get help from others. I might try to help you, but I cannot try every one of you. I cannot help every one of you. So maybe you have to find your peers who can help you, or you can help them. So in the beginning phase is going to be very important. And that's what I mentioned. Coding is fun, but it's going to take some time. So you need to show that patience. You need to be in the game. Otherwise, like, you start developing your fears from coding, and I'm concerned about the people who are not in CS background and they end up doing this the programming job. Another thing is, like, I'm not expert in teaching programming. This is for the first time I'm doing that. Though I'll do my best. I'll try my best. I have a lot of experience in programming, but in terms of teaching, I've never done programming, teaching on programming. But yes, like, mathematics, I've been teaching from last 18 years. So I have those skills of teaching mathematics. I'll try to use those skills for teaching programming also. So this first lecture is about, like, earlier I thought I'll cover like only the programming part, not the fundamentals. So I created a document which I give it to you. But later I thought I need to cover some basics so that your the start should be smooth. So I'll be spending half of this class, maybe 60% of this class, in going through the basics which I wrote in the document. Right, so some of you might know them who have done programming in your 12th class, or you have done programming in your first year of the college, because I know some of you are from the second year and third year also. So, but for your smooth start, I'll spend some time on going through the fundamentals also. So this is the first thing. I'll start with the fundamentals of the computer architecture. So this is not programming, and you'll never need to come back to this thing. But if you're writing code, it is very important to know that what happens to the code, how this code, can becomes a program. Program means that application. How this your code you write becomes an application. Application is something which you use in your day-to-day life when you sit on a computer. For example, the webinar software you're using to see this webinar is also is also a program, is also an application. Microsoft Word, which you use very often, is an application. Microsoft Excel, even a browser is an application. So somebody would have written a code to create the browser. So how this code becomes an application, and how the computer hardware, the machine which is sitting in your house, how this thing is related with your the code you write. So basically the computer architecture, or a computer which you have at home, it is based on the architecture proposed by Newman scientists in, I think, 1943 or 1945. So all the modern age computers are based on the same architecture which he proposed, like, way back in 1945. So this architecture has like 5 components. So I'm not going to teach you theory, like theoretical class, but just 10 minutes in explaining you these 5 components. Among these 5 components, but before we go into these 5 components, see the fundamental of what computer does. The fundamental thing what we expect from the computer is that it takes some input, which we can say as data. That's your computer. and what we expect is it should process this data, process this input and create an information out of it, information that can be useful, right? So whatever application we write or whatever way we use computer, it should generate some information that we can use, that we can consume. That's what we expect from the computer. So all the computers have this architecture where there are 5 elements, and out of these 5 elements, the first element is the input. There should be a way for a computer to take input from a user, and there is another element, output. There should be a way for a computer to show back the information to the user, and that is what we say as output. So typical example of input is your keyboard, right? Or it can be your mouse, or it can be some scanned document, or you can say scanner. So anything that feeds information into the computer is an input, right? For example, keyboard, you type in keys and it goes into the computer. Mouse, you move your mouse and it gets the coordinates of the mouse, they go into the computer, and then click of the mouse, you choose things, you click. So all these things go into the computer as input. And output, typical example of output is a screen, right? The information you see on the screen is an output. Another example is like your printer, you print documents, or even the file, PDF file, or those kind of files. It's like a way of throwing information into a file, showing output, showing information. So these are the 2 elements out of among the 5 elements. The main element is what we call as like arithmetic and logical unit, right? And then we have a control unit. So together they reside in what we call as CPU. Heard of this word? CPU is like brain of a computer, central processing unit, and this central processing unit is embedded in a chip that we call as a microprocessor. This functionality is given in the form of a microprocessor, right? This central processing unit is a concept, this component resides on a hardware which is we call as a microprocessor. Microprocessor i5, i7, these are latest microprocessors, and before that we had Pentium, and then 286, 386 X series family of microprocessors. So these two components, arithmetic and logical unit, it sits in the microprocessor, we say CPU, and the control unit. There are a few other components in CPU. For example, very important component is like registers, and then we have bus. So I remember I did all these things when I was at IIT. I did electronics, so we did a course on microprocessor, and we understood all these things in great detail. So, but I am not teaching you that course here. I'm just giving you the fundamentals here. So these are the 5 elements which I mentioned: first element, second element, third element, fourth element, and I'm not counting them among the 5. The fifth one is the memory. A memory is what you call as a RAM. Memory can be secondary memory also, which is your, you can say, hard disk storage memory, or secondary memory, or auxiliary memory. There are different words to say this. Or I can write hard disk here. It's a different kind of memory also, the ROM memory, which is permanent kind of memory, where like when you start a computer, all the drivers like they know, like all the drivers of code to control your devices like printer and all, how to read from them, they reside in this. So that's not important to understand in this class what ROM is. So these 5 elements: the input, output, ALU, CU, and memory. So how it works when you write a program? Program is like an instruction that you give to this microprocessor, or you can say CPU, that if you want the work to be done, so you have to give commands to this machine, and you give commands. The commands you give are known as instructions. We call them as instructions. So what you like, the instructions you give to this, they resides in memory. They are loaded into the memory, and from the memory, this is a life cycle. Suppose you say you want a microprocessor to add 2 numbers. Simple thing, arithmetic thing. You add 2 numbers. So your 2 numbers and the instruction that you have to add them will be loaded into the memory, and from memory it goes into your control unit. So control unit is something that controls the flow of the program. So it decides when to read data from input source, when to send information to arithmetic and logical units. So all the brain, all the calculation are done in ALU, arithmetic and logical, whether A is greater than B or B is greater than A, or when we have to add two numbers, A added to B. So all these things, calculation part and the logical part, is done in this chip known as arithmetic and logical unit. Uh, so control unit takes your code instruction that you write, and it passes, and then and it decides what to be done. If something is to be done from ALU, it passes to ALU and those kind of things. So register is kind of a temporary memory that is used by ALU or maybe sometimes CU to load its data. For example, if ALU has to add two numbers, so it will store two numbers temporarily on register. It's a temporary way of storing that. It load the first number, and then it will load the second number, and then it will add the two numbers. If third number is to be added, it will load the sum of the first two into register. It will save the first two into registers. Temporarily, as a calculator में होता, आप you say memory in, you add first into numbers and then you say memory in. So the register is kind of a memory in. And the bus is like basically all the communication, all the message passing is done on the bus. Bus is like a channel. It's like wires through which the signals are being passed to different components of the computers. So this is a basic component, but modern computers are not like 1943 based computers, but the architecture is same. For example, if you have to say arithmetic and logical unit, there are multiple ALUs in one processor. And there are, like, for example, graphics. We have separate different ALUs who does the graphics thing, who does the calculation for graphics thing. So that way architecture is same, but the computers are much more complex than what we used to have in 1945. So what you need to understand is the code you write, it becomes instruction, and these instructions are passed to the central processing unit, who process these instructions with the help of ALU, with the help of input port, output port, or input side or the output side, and it does whatever instructions are given for. It performs that job. So this is something diagram which I even made. It's there in the document which I give it to you. So I've just shown all the components here. This is the memory component, right? And this is the input. This is the input, this is the output, this is the memory, and this is the central processing unit, which has a ALU, registers, and controls, and neatly done diagram. I have not made it, I just copied it from internet. So the one I made was so rough, so I thought of giving you this diagram. So this is where your code resides. यहाँ पे आपका code है जो आपने किया है, and then this code is passed into this CU, and it controls that and generates output. See, this is like, yeah, I just told you that what we pass to control unit, what is the instructions which CPU can understand, right? These instructions, this language, you cannot give instruction to central processing unit in, you can say, the language we speak, right? The higher level languages, what we can say, the languages we speak, we cannot give instructions to machine in that form. Machine has its own language that it can understand. So that language is known as, either we can call as a machine code. There's a word for this. Either we say machine code or we say binary code. So basically computer can understand instructions or data in the form of zeros and ones, 0 and 1. I'm not sure whether you have done this binary thing or not. For example, when we say it's a number 101, it means that we convert this number into a decimal format. Is that like this is 2 to the power 0, this is 2 to the power 1, this 2. So it is 2 square plus 2 to the power 1 into 0 plus 2 to the power 0. It's not important, but if you're not done converting a binary number into decimal number, that's okay. But idea is that the language computer can understand is the language of zeros and ones, right? Because computer has all the hardware. So the way it understands is if there is a, like, if there's one situation when the circuit is active or there's a current, when it's not active, it is 0. So 1 and 0 thing. So this kind of language computer can, but we cannot write code in zeros and ones, though in college in some of the courses you might have to. especially the electronics guy, because I remember I did in one of the courses we used to write with simple commands, not the complex command, like adding two numbers and those kind of things, writing code in machine language, machine code. So we cannot do that. So what we do, we write code in our own language. We call them as a higher level language or high level languages, like you have your C, C++, Java. All these kind of languages are high level languages, and we use these languages to write code. And when we write code, it's like the normal English language we write, or maybe it can be in some other language also, but daily use languages we use to write code. Now how this code becomes instruction in the form of 0 and 1, somebody has to do it. Somebody has to do this conversion, writing our high level code into zeros and ones, and that is done by, we have a block sitting here, right? We cannot do this directly, so we have a conversion module here sitting here, but is known as compiler. Compiler is also a program. It's also a program. It's already a pre-written program which takes, on one side it takes your code, high level language code, and it converts into a machine language, machine code of zeros and one, which computer can understand. So when you start programming, every time you keeps on hearing this word, this compiler, that I have to compile my program. When you say compile your program, it means you have to generate the code which computer can understand. Okay. So this is a diagram which I even gave you, you know, in the document I gave it to you. So I'm just zoom this document. So don't need to go into details of this document. It's not a right time. What it shows is, on this side, it is, you can show, it's showing you the code which you write. That's a high level code in C language. And then on this side, this is a code which computer can understand. Right? This is like a binary code or machine code. The computer can understand. So this is, you can see the guy sitting in between. This guy is the guy what we call as a compiler. Right? It compiles. On one side, it takes the code which you write and it generates the code which computer can understand. So I have another diagram to show you this, a better diagram to show you this. I don't think I can. So this is there's one more step. That's what I mentioned in this diagram. So this is your source code, the code you write, high level language, your code, right? The C or C++ or Java, and compiler takes this code. We discuss about compiler. It generates a code, machine code. Generally, suppose you say my file is a.cpp. If you write code in C++, the extension is cpp. Like for example, you write code in Microsoft Word, the extension is .doc or .docx. So this one converts into a machine code. It becomes a.obj file. Obj file means object code. Object code means 01 code, machine code. Now the object code आ गया आपका. Now object code is not a code that you can run as an application like Microsoft Word. It's not like that code. So what you do is, it needs to take this few more things. There is, like for example, there's some code which we are writing, but there is some code which is already written and compiled and in the form of libraries given to you. कि कुछ code तो already, don't write it, like you write the code, the instruction that you want computer to process, but there's a pre-written code that we use in our program. So that pre-written code which is available to us in the form of library is combined with our code. A linker combines these two code. When you say कि I want to use this for example, for printing we use a command that we don't write. For reading input from the screen, things are already available. To find the date of the system, so there are a lot of things for which the code is pre-written. They combine our code with that code, and that is done by this guy linker, and this together generates a file, executable file, or this call as an application. This is application that we run. When you go to file system and you see, or maybe on your desktop you have icons, you click icons and application runs. So on this side, this is the code we write and this is the application we get. So this is the pathway, and that's what we're going to do in this course. Though we're going to make very simple program, not complex program, not like Microsoft Word or a browser we can make in this simple course. We'll make simple programs. So but in all the programs, the life cycle would be same. You write your code, ये code आपने लिखा है यहाँ पे, and then you will press the button compile. Compiler will compile your code. It will generate this file also. But if there are external libraries also which you're using in your code, it will compile them and it will generate this executable file. And you can run this executable file by going into your file system like you run another application. Right, so this is, you don't need to worry about all this part. This is done by the compiler. And generally what we do to use this, there are two ways. One is we can use the command line software. I don't know whether you have seen that or you work that, that you open the DOS prompt. We call that as a DOS prompt, and then you generally work with a file system with a graphical UI. So most of you would be using some graphical UI, what we call as a IDE, integrated development environment. So this support from your source code becomes an application with a program that is available to you in the form of IDE, integrated development. So you maybe you've heard of this Turbo C++ is one of the applications. There are many other freely available programs and paid one also. The one I'll be using to create to create executable programs, or the machine code which computer can understand from the code I'll write is what I use is the Visual Studio. It is from Microsoft, Visual Studio, and it is free, Visual Studio Express Edition. So it doesn't matter which IDE you are using. I use it free, and it's very easy to use it because it's a modern world IDE. We call this IDE. So it gives a lot of help when I write code. So I suggest that you should use the same thing because it's free and it's very good. But something, if in your college they are using something else, they're referring something else, there's no problem. You can use that also. It's not important. So now this is the before I get into this, I would tell you one thing which I keep telling in mathematics classes also. So when you start something, it's not possible to understand each and everything. So few of the things cannot make sense in the beginning, right? So for example, if I start teaching you functions topic and at the same time I start teaching you the complex graphs, you cannot ask such questions that how I can get a graph of, you can say log x by x, and it's the first class I'm taking on functions. I'm just teaching you what is log x, and you are asking draw the graph of log x by x. No, I cannot tell you because it's not the right time. So same here, everything you see while writing program might not make sense to you at that point of time. So don't get afraid. Don't get after that to understand. Don't just start googling and try to understand those things yourself, because you would not be able to understand, because there are connected things in between. So there are some prerequisites to understand that. So, and that's okay. And whatever you can, don't just pick out whatever you can understand. Whatever you cannot understand, that's okay. So this is the skeleton of every C++ program. Whatever program we write, this is the skeleton. So this is this, whenever we write program and compile it, the control unit should know from where to start executing your program, where to start running your instructions. CU runs instruction like this. Statement 1, you write statement 1, statement 2, or in terms of machine code, we say instruction 1, instruction 2. It's the same thing. Your statements are converted into instructions. So it follows instruction 1. This is how it follows. And there can be a jump statement also, jump instruction also. Jump karna hai, jump to I7 and I5, and then from I5 and then I6. I6 is jump to I4. So this is the way machine code works. It goes sequentially, but if there is a jump, it jumps. Now, but it needs to know what is the starting point of your program, from where it starts executing the instruction. So the starting point of every program is this main function. We call this word as a function word, or it's basically a function, or it's a procedure, or it's a method, whatever we want to use it. It's whatever, like this is our entry point. And we compile a program, so it looks for the main thing, and it puts this as the first instruction for CU to execute. So this is the entry point of every C++ program. The entry point, and this is the exit point. When this function finishes, this exit point. So whatever we want, instruction we want to write, it should be between entry point and exit point, right? So every C++ program will have this structure where we have to start writing our code from this starting braces till ending braces, between these two. And see, this is the name of the function, what we call as a main. This int is a return type. What when this function executes, it returns a number. We don't get into that right now, what number it returns and what is the use of that. It returns a number, and the type of that number is integer. राइट, उसकी जो टाइप होगी, जो नंबर आएगा वो इंटीजर टाइप का नंबर होगा, वो रिटर्न करना है। और तभी वो सी दिस इज रिटर्न स्टेटमेंट। रिटर्न स्टेटमेंट मींस कंप्यूटर वांट्स टू रिटर्न, दिस इज RETURN, कंप्यूटर वांट्स टू रिटर्न 0, इंटीजर रिटर्न करना चाहिए, कंप्यूटर इज रिटर्निंग 0. So in every C++ program we have this structure int main, we have this bracket. I'll come to this bracket just in a moment, and this starting braces, ending braces, and this return 0 to indicate compiler that from this program we're returning 0. That is the end of the program. The moment the return statement comes, your program ends. This is a terminating condition. It means you stop executing your program. So this structure will always be there. Now we have some thing written inside this bracket. So this is what we call as, this is not again important to understand, I'll just touch this. This is what we call as a command line, command line arguments. So whenever we run a program, we can pass some initial instructions to the program. That is done through in the form of command line arguments. Generally, when we used to compile programs on the DOS prompt, we used to give these, you can give these or when you're running in a visual environment, there also there's a way to give the command line parameters, command line. So this is uh, uh, argument. Gives us the count of the argument, how many arguments, how many data. It's like passing data to your program, how many data points you're passing to your program. Kitne aise number, for example, you want to pass 5 integers to this program, you want to pass these list of integers 5, 10, whatever is your program. For example, your program is to find largest number of these 5 integers. So you pass these 5 integers, 5, 10, 15, 20, 7. So this will be 5. Number of arguments you are passing is 5, and this is the list of the arguments, list of the numbers, or list of the arguments. So it's a way of passing data to your program. This is how many data points you are passing, how many numbers you are passing, and this is a list of the numbers, actual list of the numbers. But see, right now we are not going to use that. We are not passing any parameters to the function, so we can, there is no need to even write it. We can just keep it blank. उसको लिखने की जरूरत नहीं है, अब blank रख सकते हैं उसको आप, ऐसा है. But there's no, so for most of the programs we write, this is the skeleton we use. This is the, you can say, format we use. I'll show it on a computer also, but just to give you idea, this is the skeleton of a very C++ program we write. We are not, again I repeat, this is the this is a type of the number it returns, right, int, and this is where it is actually returning 0 to indicate that our program is ending here. There's no need to do anything else. You can just quit, you can exit, everything is done, right? And this is the main function. Name of the function is the entry point where our program will start executing. These are the you can say data points which are being passed to our program, or we can pass to the program in the beginning. This gives us the count of the data points, and this is the list of the data points, and I told you we're not going to use this in the beginning. So this is like what we call as we already saw this skeleton of C++ program. Now this is what we, this one more thing, the preprocessor directives. Again, it is difficult to understand at this stage. I can just briefly touch this point here. So the point is that, like, whenever we have the, like I just told you in the beginning, that some of the code we are not going to write, we'll be writing, we'll be using, which is like the code which we'll be using, the code which is already written and given to us in the form of a, you can say, standard libraries available. So that's this preprocessor directive is what we do is we say hash include. This is what we use, hash, we write hash include, and then we write the file name. यहाँ file name लिखते हैं हम ऐसे यहाँ पे. Either we can do this from, follow this, sometimes we do this and sometimes we do this. In quotes we write name of the file. For example, xyz dot I don't worry about the extension, I'll come at later. File name xyz, and this is abc, like this. So this is a way of including the pre-written code into our program to get the functionality of pre-written code. For example, if you want to write something on the screen, we have to use this command. We'll again see this in a few moments. Cout, we say cout or cout, C-O-U-T. But we are not writing this code to print something on the screen. So, but we are getting this functionality through a pre-written file which we call as IOStream, hash include IOStream. We use in angle bracket IOStream, like this. So this pre-written code is already available. We just include that, include in your code. right? Other thing is other place where we use this preprocessor directive is sometimes we write a very big program and we don't want to write it in one file. We want to create, like for example, this is a lengthy program you're supposed to write. So what we do is to organize it better, we write program into small files based on the functionality. This guy does this guy does this guy this. So we break this into multiple parts. It's a big program. We make multiple parts. Now to join all these multiple parts, what we do in the in the file where we have the main program, where we bring the functionality of all these files, so we include all these files to this hash include. तो जो आपके मल्टीपल पार्ट्स बना दिए सारे पार्ट एक जगह लेके आने पड़ेंगे एक फाइल के अंदर. वो पार्ट इंक्लूड करने के लिए we use hash include. Again, this is a basic introduction that you cannot go in detail because the first class you have never done programming before. So, but we have to use it. So I have to mention that preprocessor directives are used. It's like a way to include already written program, already written libraries into your program. If you want to get functionality of already written code, that's how you include. Or if you want to include functionality which you have written, it's not already given to you, but you are writing in some other files, right? The instructions you're writing in some other files you want to include in this file. That's how you include them. Either it is pre-written for you, like it's already available for you, you're not written them, you include here, or you write in some other file and include here. So it's like including already pre-written code into this file. So almost I've touched some of the theory points, but beyond this, it doesn't make sense to do it on a notepad kind of thing. It makes sense to do it on actual software. The idea I talked about. So I'll show you. This is the this is the let's. So this is the program idea I was talking about. Say Visual Studio 2012 Express Edition. Express Edition is a free edition, but people also use it for professional purpose. So, and professional version is a paid version, but Express Edition is for students to write programs, and it's freely available. So what I do, I go there, I start a new project, and I chose like maybe the first program. So you don't need to do anything else. Whatever is on this side we are choosing, it's a console application. So these things are not going to make sense to you, right? So we're writing on this side, we're choosing Visual C++ because we're writing code in C++, but same ID can be used to write code in Visual Basic and Visual C Hash, Visual C Sharp, but we are writing code in C++. So we choose Visual C++ on this side. On this side we write console application, choose the file name. So it doesn't make sense to understand this right now because we don't have the same software. So if you're using the same software, then it makes sense to understand. So he's saying this file name directory name is already available. So I say first program 2, I change the name. So this is, let me increase the size of this. I say 200. So you can read this. So this is the IDE, or we can say software we are going to write our C++ programs. So if you're not using the same ID from Microsoft, if you're not using the ID from Microsoft, you might have a different view. So this is, this is what I told you was hash include. So this time, we are not going to touch this. I have not written this command. It's already there, provided by Microsoft IDE. So this Microsoft is using this for maybe for compiler to give some instructions. So we are not going to touch this. We are not going to change this. It will just let it be like that only. This is like if you have to write something, but we don't want to include that. We want to write a comment here. It's not a code, not an instruction. You can see we use this 2/ like this. If we don't want to include that in the program, whatever we write is not going to be in instruction set. But if you write something like this, it's a problem. Computer will think, compiler will think it's an instruction. We want to give it to the it's the instruction in which it has to compile into to generate 01 code, but it's not an instruction. So whenever you want to write a command or something that you don't want compiler to see, you just hide them below this, hide them like this by putting two forward slashes like this. So now computer will, when the compiler will understand this is not something which he has to do. It has to ignore all these things. We call them as comments. See if we so if we see, this is the, I was talking about the main program. So Visual C++ has their own version of main program, so I'll just remove this, and what I told you the main program, I'll make it the main program. And I told you we're not going to use this command line argument, so I remove this. So this is the skeleton I was talking about. This is the main program, entry point into every C++ program. This is a return type, and this is where actually we're returning 0. Right now, like for example, if we have to write code to print hello world out on the screen, it's a tradition that whenever you write your first program, you write hello world. Though it's not necessary that you have to follow this instruction, but there's no harm in doing that. We have that first code you write in any programming language, you have to write hello world. If you want to change it, you can change it. So let me write hello world. So if we have to print something on the screen, I'm not going to write the low level code to at a driver level that you have to write on the screen. If you have to write on the screen, you have to just work with a driver that generates as output on the screen. I don't know how to do it. I'm going to use this functionality. This is, I'll include, which is already available. I have not written this code, IOStream. This library is already available. Now people are asking that what do you mean by IOStream? I'll come to that. So, and then now to write the hello world on the screen, I use this cout statement. This is a format to write. Let me write it and then I'll explain it. See, so this is the first program we have written where we are saying hello to the world. Let's first of all run it, build it, generate C++, generate 0101 code so that computer can understand. So we build this program, it generates, it's a compiler which is compiling the program. I will run this program. Just a minute. So you can see hello world out there. We could write hello world. Now what we did to write this hello world on the screen. So you can see the functionality where this is the functionality. IOStream is a pre-written library of functions which is available to us, and this library is to read. It's like reading a stream from the screen, or sending a stream of, you can say, characters or numbers on the screen. So reading from the screen and writing on the screen. So the functionality, this functionality is already pre-written and provided to us in the form of IOStream. So we have to include this if we want to use functionality. And inside that we have this we have the cout command. The cout is a command which helps us in writing this hello world on the screen. This is a format. You cout and then two angle brackets like this, and open, it's less, you can say the less sign to two of these angle brackets and hello world. So we have to, whenever we have to write on the screen, we have to follow this format. Now what is this std? We can remove this std here. So basically all these functions, the cout, scene, many other type of functions, they are grouped together in in C in you can say a namespace which you call as std. I can give you an analogy to explain you this. For example, if there is a country, and in a country there are multiple cities. So if you have to reach to a city, then you need a name of the country. So IOStream is analogous to name of a country. So if you this is the name of the country, we have to include name of the country. We have to decide name of the country if you want to visit a city. But if you want to get to a city, but city is inside a state. You need to have access to the state. So you need to mention the state before you say city name. In India, maybe I'm not sure, but I know about in US, city names are repeated. In the same city name you'll find in multiple states. For example, the city I live in US is like Los Altos, and there are many Los Altos in United States. So if I say I live in Los Altos, somebody will ask which state. Which state? There are multiple Los Altos. I have to mention California. Los Altos in California. So same way, IOStream is like a country, and cout function is like a city. But between country and city there should be a state also. So the state is like this std thing. Either we write either you mention std here. Every time you have to write std like this colon 2 times, right? If I suppose if I hide this using like this, if I make it a comment, then I have to again, it's showing a problem. This is showing a problem because this functionality is end of line character. It's end of line. It changes the line. It brings character to the next line. It's the next of line or end of line. So we have to write this std before this also, because this function is also in std. It's like and same as we have to do with this. So now the namespace thing is, every time you have to write std colon before for every name of city, before every function or functionality we want to use. It's a command to print this on the screen. This is the command to change line of to go to the next line. So you need, so this is for the next line. So you have to write std before every command you write. So instead of writing std before every like this instead of writing std like this before every function we use from IOStream library, right? इस library का कोई भी function use करेंगे आप, कोई भी country की city की बात करेंगे तो आपको use करना पड़ेगा std. अब वो हर बार करने की बजाय it makes sense that we remove from everywhere and include this at the top, and include this at the top. Name of the state, we can include this at the top like this using namespace. Using namespaces. So state name is like a namespace, right? So all the functions are grouped together, and they're grouped together. The name of the group is the namespace. Name of the group is std here, right? So this is the first program we wrote, and if you see this, if I remove this end of line character just to see how this end of line thing works, if I remove both of them, Control X, and then semicolon at the last, and if I rerun this program, you can see press any key to continue. We don't write it. It's for the system is generating this line. Otherwise, the window will go away. We run the program, window will go away. To hold the window so that we can see our output, we can see the screen. So we're not doing that. System is automatically does this thing at the last. Press any key to continue to close the window. So you can see hello world. Once the hello word is printed, our cursor is just on the right of D. D के right पे अपना cursor है. अब D के right पे जो cursor है उसके बाद ही यहाँ पे print हो गया. But we want some gap here. So you want this press any key to continue to come to the next line. If you want it to come to the next line, see what we do is, यहाँ पे हमने end of line character print कर दिया. जैसे हमने पहले print किया था hello world, we print this end of line character. So if you see, if I run this, what will happen? You can see press any key to continue is now in the next line, because it changes the line. End of line character changes the line. If I put another end of line character here, if I put another end of line character, so it will generate a blank line. See, you can see. So first end of line is bringing cursor here. Second end of line is bringing cursor here. So just whenever you have to leave lines in between, you use end of line character. So that's what we discussed printing on the screen. So other thing, before we start, we need to understand what are constants, what are variables, and what are data types. So let's do in the ID form. See, in mathematics also, whenever you need to assume a number, assume a variable, you define the type of it. What we call here is a data type. If you remember, like when we say let x be an integer, that's how what we used to do. Let x be an integer, let y be a real number, let z be a complex number. We need to, whenever we need to assume a variable, we need to define type of the variable, right? For example, uh, like and in physics also, if you say v is the velocity of the car, you need to define, like you say, it can be a integer value, it can be a decimal value also. So you say, though we use the term real number in mathematics, but in computers we need to we have a predefined types, data types. So the three prime data types are integer type. We write them as int, short form int is, otherwise it's an integer. Other data type is what we have is like a double. Double is for decimal values. And third is the char. Char is to represent the characters, the ABCD kind of characters. Characters represent करने के लिए. And whenever we have to define a variable, suppose you want to define a variable of the type integer. So this is what we do. We say type is integer. We define integer. You can name it anything. We can choose any name for the variable, like you do in mathematics. You can say x is a variable, or x1 is a variable, or x2 is a variable. We can choose our own name for variable. So I'm defining a variable init1 because we need to define a variable, because sometimes we need these variables to hold data, to hold values. That's why we need to define variables. कुछ भी करना आपको तो variable define करने पड़ेंगे so that they can hold data. So you're defining integer one variable which can hold data, which can hold an integer value, and this is what we can do. We can say we can say init1. We can assign it to a value. You can assign a value to it like this is equal to 10. Right? We can define another value of the type double, say, double one, of the type double one, and we can assignment can be done in the same line. First, this statement says this, according to this statement, is to assume a variable of the type double, and when I say equal to say 2.5, I'm assigning a value to this double variable. It's like initialization. I'm initializing this variable to a value 2.5, and something similar you've done in mathematics. Let x be a real number, and then we say let x equal to 2. So this is initialization of the variables. Another thing we can do is I can say of the type character, I can say variable is char a, char1, and say this is assigned to value a. This character thing is, it can hold only one value, right? It can hold only one value. It cannot hold multiple values. Single character, it can hold only a single character. We cannot say a comma. If we cannot say this, if you say this, see what will happen. If I suppose I do this ab, it cannot hold two characters. If I give them two characters, what will happen? See, if I print this, see out, I print this character. So if we have to see this command, I'm saying see out is print on the screen what character 1. So when I use see out command, I can have see out can be like this, where I'm giving the constant string, fixed string, hello world between the quotes, or I can say print the value of the character 1, see out the value character 1. I don't need to put quotes. Don't put quotes here because it's a variable. Quotes will put only when it's a constant thing. If it's a variable thing, we don't need to put quotes, right? And I would prefer to put end of line character so that I get some space there. If I run this program, see what will happen. Wait. Oh, I have to compile it again because it's running I have to build it. Oh, there's showing error because, so it's showing the same error that can I use. Yes, because it's showing it's not going to work because we are trying to assign the two characters to this. Oh, it's okay. That's a mistake. Should be single quote. see if I, so what will happen if you run this program. Oh, why is not printing? Oh, that's the problem. We are, I was wondering what's happening. Why is not printing? Because see, I put a return 0 here. So uh, return 0 means it's returning 0. It means the termination of the program. If you are terminating program at the top, that's why it is not coming. These, it was not executing these statements. So you can see it printed only the value A, not B. Oh, sorry, we just changed to A and B. If I say A and B, so it printed the B. So I was explaining you that this char variable, it just printed B. Char variable can hold only one value. So what is happening here? It is not showing the error. And before that, you need to understand that like every variable is pointing to a cell in the memory. Memory is like, you can say, the cell of arrays. It's like you see a table where there are rows and there are columns and there are cells. So for the memory structure, you can visualize in this memory structure also, you can visualize in the same way. It's a two-dimensional array of cells, and every cell we write numbers, and generally the every cell has a width of 1 byte. I don't want to get into that right now. I'll explain in later stage. But right now you can understand that the variable, like every variable, if I, so it is like this, every variable. So this is suppose our memory, and these are the cells. Goes on like this. So for example, char would be this. For example, we say char1. Char1 is address of a cell in the memory, right? So when we say char1 equal to colon A and B, so first of all, char1 writes A here, and then in the stream we are then we are saying A first, assign A, and then B, and after that immediately B comes, so it overwrites with B, right? So that's the structure of the memory, that in memory we have cells, and in these cells we store the numbers. And char1 can hold only one character, so it will use only one cell. So first of all, char1 is assigned to A, it saves A here, and then char1 is assigned to B, it saves B. So it finally just we got B. char1 cannot be AB because it has a capacity of holding only one character. तो जो character बाद वाला character है तो वो वहाँ पे आ गया. So same way integer1 है, integer1 भी हमारा if you say init1 is pointing to a, but init1 see is can अभी it's not important right now, but init1 is of 2 bytes. It will span will be 2 cells in the memory, because it can hold its capacity is 2 byte, it can hold a bigger integer. So the space it will take in memory is 2 cells, not 1 cell. So we'll discuss this at a future stage. Right now is not the right time. It's more theory. So what you need to uh, visualize right now is that memory is like it's a two-dimensional array where the cells are the cells are the places where we store numbers, In cells we store number. A number can be just stored in one particular cell. If the number is small, a byte, then it will take only one cell to store. But if it is a big number, it will take multiple cells to store. And every variable is like an address to the cell. So if you assign a value to a variable, that value is saved into the particular cell whose address is the variable name. So double one is pointing to a cell in the memory, and no, multiple cell. Double one will point to multiple cells, and it is storing 2. The moment you said double one is 2.5, this 2.5 value is saved in the memory and where whose address is in double one. So that's what we discuss, how we these are our data types, and this is how we assign them. Now we have a data type which we call as array, because these variables, whether it is integer or a character or it is double, they can hold only a single value. For example, init1 can hold a single value 10. But if you change it, if we say init1, reassign it, say 20, now 10 is gone. It is not equal to 20. So every variable can hold only one value. Now suppose if you want to save marks, scores of 100 students in a class. There are 100 students in a class, and you want to save them in memory. So I'm not going to define 100 variables. Student 1, student 2, student 3 up to 100. I'll go mad if I define 100 variables here. So what I do, I use a different data type which is known as array. ARRAY, array. So I use it. This is the way I do it. I say, and because in memory I don't want to just use 1 or 2 cells. I want to use 100 cells. So I take a block of memory, block of 100 cells, right? Or maybe 200 if you're saving integer. So every integer will take 2 cells, a block of 200 cells, and assign a name. So what I do is I say I'm going to save integer there, and the name is say scores. नाम दे दिया. Right, equals to and this is how we brackets we use. If you use this square brackets and I write 100, so this 100 indicates that I want to save 100 marks of 100 students in this array, like this. So this is my two-dimensional this is my array, one-dimensional array, but one-dimensional array means it's just not in the form of a grid. So now it can save. I can say in the 0th cell, the address starts from 0th cell, say marks for the first student. Say first student got 100 marks. In second cell, say marks of second student, say he got 50 marks, goes on like this, right? The last cell we have defined as 99. I can say, right? But what will happen if I say score, if I try to, wait. Let's first of all print these. If I have to see the values, this I say, so I'm using only one variable name, you can see scores, and I'm able to save scores of 100 students with one variable name. This data type is known as array. And just by putting these brackets, see bracket आपने square bracket लगाते ही 100 उसको memory cells मिल गए. I print the values of the first one, say this, and I also put end of the line character. And I make copy of this. Value in the is it 51st cell? Remember that if I write 50 here, it is 51st cell because cell starts from 0. $99. Now we don't want to say hello world again and again, so I just comment this out. This part I'll comment this out. I don't want this. See, if you have to comment this whole part, instead of every time saying every time using this forward slashes, so what I can do, if I have to comment a block of code, I have a different format, the C style of commenting. We say it's a C style of commenting. I use forward slash and then I use a star. this is beginning of my commenting and I want to end my comment here. That's how what I do. So I write my code. See, like this. You can see if I this is the beginning of my commenting and this is ending of my commenting. Anything between these two symbols, these two forward slash star forward slash, any code between these two will get commented. So that's if you this is we use this if you have to comment a block of code. But if we have to block, if you have to comment a single line, then we use forward slash. It's much easy to use. But block of code karna hai, then it's much easier. Right now, if we run this program, we build this, so there's no error. Then we run this program. You can see we get 100, we get not defined value, and then 99. See what we did. So this is we print 0 or 50th. I choose 50th, but I didn't assign a value to it. But in memory some value must be written there. It's a random thing. Memory में अगर 50 जो cell जो sign मिला वहाँ तो कुछ लिखा होगा वो print हो गया यहाँ पे. कोई random number default number लिखा होगा. If I say 1 the value 1 print होगी. If I print this again, you can see then the values I assign. So if I don't assign a value, there's no error. The value what is pre-written in the memory, it shows that value. The other thing is, suppose what I'll do, हमने बनाया array of 100 elements 0 to 99. If I say 100 here, it will show an error because this is not I have defined array of 100 elements means starting from 0 to 99, and now I'm saying 100 here. So what will happen? Is it going to show error? It's not going to show error. Why? Because see, let's run this first. See, so basically it's not showing error. It is because I told you it's a memory is it's like a two-dimensional array. So we were allocated a memory starting from a cell up to say 100 cells, right? Or maybe 200 cells because each cell, to save an integer, we need 2 cells for each integer value. But if you want to go beyond that, the memory है वो तो कुछ होगा, memory में number होगा, blank number है, dummy number है, वो प्रिंट हो गया. एरर नहीं आई है, हमने इट्स अ वे टू एक्सेस बियॉन्ड, जितनी हमारा स्कोप तो उसके बाहर निकल गए, 100 पे चले गए. मे बी अगर आई थिंक अगर 200 भी दे देंगे तो कुछ होगा. इट्स नॉट गोइंग टू शो एरर इफ वी रन दिस. राइट, सही. वहाँ 0 लिखा था 0 आ गया, वहाँ 0 होगा उस टाइम पे. दैट्स द आइडिया. So it's not important, but just to show you that if you go beyond beyond your allocation, then it's not an error. But obviously, like you're not using that cell, you're not assigning the value to this cell, so waste for you. Right? Let's see what we have next. So next is how we can read data from the screen, and then this is not important. So we can get to programming. So see, if we have to read something on the screen, how we do that? It's a very simple thing. Like we use cout for printing on the screen. For reading on the screen, we use this command. We say enter we use scene as a command to, and we use the angle bracket in different direction, greater sign, two greater signs, you can say. This is the command whenever we want to read something on this. But if we have to read something where we are going to store, so we need to define a variable. We need to define an integer variable. We say get data, right? I define a variable get data, and I say read the value and save in get data. That's what we do. Right, so maybe you're new to this, but it's something very easy. And then you can say you typed right. So this is simple 3 lines program, and what it is doing, it is asking user to enter an integer, and then it is defining a variable so that the value user will input, it can save that value. To save the value, the user will input. So this is how it is reading. It will wait for user to enter the value. The scene, when the moment it comes to scene command, it will wait for user to enter the value, and then it is printing that value again to show that you type this value. Now if you run this program, see, enter an integer, I say 20, so you type 20. See, so just to illustrate you how you can read data from the screen, how you can ask user to input a data. So we use this scene command, and whenever like user will type something, there should be a variable to hold that data. So we are defining variable first, and then we are defining init variable, and then we are saving the input which user is giving in this variable, in this memory location, and then we check that everything went okay. The value we saved, we are able to retrieve that value. यहाँ पे जो get data हमने value save करी उसको retrieve करके भी देख लिया हमने. See,